Hello and welcome dear students. Today we are going to learn problems on the maxima and minima from the topic applications of derivatives. So let us see first problem. Divide the number 20 into two parts such that sum of their squares is minimum. So we have to find two parts of this 20 number such that condition given, if we take sum of their squares, always that minimum. At that time when the sum of their squares is minimum, we have to find which are two parts of 20. Let us see here solution. Let one part be x, that is one part of 20 be x, and therefore the other part will be 20 minus x. If we add these two parts, we get 20. Let s be the sum of their squares. And therefore we can write s equal to, or s becomes function of x here, sum of their squares. First part x taken, take its square, plus second part taken 20 minus x its square. So we have taken s of x as function, that is sum of their squares. Next part similar, find first order derivative s dash of x. So derivative 2x plus derivative of second term 2 into 20 minus x into derivative of minus x is minus 1. So it is equal to 2x multiplied by minus sign and this 2. So minus 2 into 20 minus 40 minus minus plus 2x. So 2x plus 2x 4x minus 40. Now next step, we solve the equation s dash x equal to 0, and which gives that right side 4x minus 40 is equal to 0, and this gives 4x is equal to 40, and therefore x is equal to 40 divided by 4 means 10. So we get point as 10. Then from equation 1 we find second derivative. So from 1 we find s double dash of x, second derivative, derivative of 4x 4 here, derivative of minus 40 is 0, and therefore substitute this point 10 here. When x equal to 10, we find second derivative at 10. See, here right side is constant, that is 4 as it is, and we know that 4 is positive, that is greater than 0. So we get here second derivative is greater than 0. Therefore by the second derivative test, s is minimum here. Second derivative greater than 0 means s is minimum, and we know what is s? S nothing but sum of their squares, and that is what to show. S is minimum at point x equal to 10. X is the first part. So when x equal to 10, we can find the other part. So other part is, we have taken other part as 20 minus x. So x means 10, and that is equal to 10. Also get other part 10, first part 10, and therefore the required two parts of 20. Are 10 and 10 when the sum of their squares is minimum, and the solution completed. Let us continue. Second problem. A wire of length 36 meters is bent in the form of a rectangle. Find its dimensions if the area of the rectangle is maximum. So, we have to find dimensions of the rectangle. That means what is length and breadth of the rectangle. At that time, we have to show that area of the rectangle is maximum. So, let x meter be the length and y meter be the breadth of the rectangle. Suppose rectangle of this type. So, we have to find x and y here. We have to show area is maximum. So, here wire of length 36 meters is given. That means length of this rectangle is given. That means perimeter of the rectangle is given. Since perimeter of rectangle that is given, perimeter means sum of all sides, and that is given 36, and we know formula for perimeter of rectangle, that is 2 in bracket x plus y is equal to 36. So, this gives x plus y equal to 36 divided by 2 means 18, and from this we get y equal to 18 minus x. Then we have to show that area is maximum. We let here capital A be the area of the rectangle. And therefore, we know formula area of rectangle equal to length into breadth, length x and breadth y. So, a becomes function of x if we replace y by value 18 minus x here. Y is 18 minus x, and we get this function. Simplify 18x minus x square. Next part similar. Find first order derivative. Derivative of 18x, 18, derivative of minus x square minus 2x. Next step, we solve the equation a dash x is equal to 0, and which gives that 18 minus 2x is equal to 0, and this gives 2x equal to 18, and x equal to 18 upon 2 means 9, and we get point as 9. Next step, from equation 1 we can find second derivative. So, a double dash x is equal to derivative of 18 0, derivative of minus 2x minus 2. Okay. So, when x equal to 9, we find second derivative at 9, and right side is constant, that is minus 2, and which is less than 0, negative. So, I have shown that second derivative is negative, and this shows that by second derivative test a is maximum at x equal to 9. So, when x equal to 9, we can find y. So, what is y? We have taken y as 18 minus x, and x means 9. So, 18 minus 9 is 9. So, we get y equal to 9, and therefore, when the area of the rectangle is maximum, we have shown it is maximum, the dimensions of rectangle are 9 meter and 9 meter, that is length is equal to breadth is equal to 9 meter. That means it must be a square. So find the dimensions of the rectangle. At that time we have shown that area of the rectangle is maximum. Okay. Continue. Third problem. What is given? A rectangular sheet of paper has its area 24 square meters. Area is 24 meters square given. The margin at the top and bottom are 75 centimeter each, and at the sides 50 centimeter each. What are the dimensions of the paper if the area of the printed space is maximum? So you have to find here what is the length and what is breadth of this sheet of paper. At that time we have to show that whatever we print on this paper, that area of printed space must be maximum. So when the area of printed space is maximum, we have to find what is this, say, length or breadth. What is this breadth and what is this height or length of this sheet? That means we have to find x and y here. So first we let here x meter be the breadth and y meter be the height of the sheet of paper. Since given that area is given, since its area 24 meters square, and we know that area of rectangle sheet in the form of rectangular sheet is given. So area of rectangle formula is length into breadth, x into y equal to 24, and from this we can find y, that is 24 divided by x. Then we have to find dimensions of sheet of paper. So first we find after leaving space, after leaving margin at the top and bottom given that 75 centimeter, and at the sides margin is 50 centimeter at both. Okay. So after leaving margins, the dimensions of printed space will be, here breadth will be, total breadth of sheet of paper is x, and we leave margin 50 centimeter here and 50 centimeter here. Given area in terms of meter, square meter, see here unit in terms of meter and here given in centimeter. So 50 centimeter plus 50 centimeter, that is 100 centimeter, that means 1 meter. We subtract 1 meter from this total length x. So x minus 1 meter, and height will be y. We leave margin here 75 centimeter at the top and 75 centimeter at the bottom. So total 150 centimeter, that is 1.5 meter. So we subtract 1.5 meter from this y, that is nothing but height of this printed space, y minus 1.5 meter. So after leaving margins, the dimensions of printed space will be x minus 1 meter, that is the breadth, and y minus 1.5 meter, that is the height of printed space. Again let here capital A be the area of printed space, and therefore A equal to x minus 1 into y minus 1.5, length into breadth. A becomes function of x if we replace y, so we get x minus 1, and what is y? Y is 24 divided by x minus 1.5, and simplify this. First multiply by x here, so x cancel, we get 24 minus 1.5 into x multiply by minus 1, so minus 24 divided by x, minus minus plus, we get 1.5. Then I find first order derivative, that is a dash x differentiated with respect to x, the rate of 24 is 0, minus 1.5 constant here, derivative of x is 1, minus sign 24 constant, derivative of 1 upon x, we know formula, derivative minus 1 upon x square, and derivative of 1.5 again 0. So we get here minus 1.5 minus minus plus 24 divided by x square. So here 1.5 means 3 divided by 2 plus 24 divided by x square. Next step, we solve the equation a dash x equal to 0, and which gives that right side is minus 3 by 2 plus 24 divided by x square is equal to 0. We solve this, cross multiplication, minus 3x square plus 24 into 2 48 divided by 2x square is equal to 0. So get here minus 3x square plus 48 is equal to 0, and therefore 3x square equal to 48, and therefore x square equal to 48 divided by 3 means 16. So we get x equal to plus minus 4, but x is the length, cannot be negative, and therefore we take x equal to 4 here. Then we find second derivative from a dash of x. So from above equation 1, second derivative a double dash x is equal to derivative of minus 3 by 2. What is a dash x? You know, this is a dash x, minus 3 by 2 plus 24 of x square. Derivative of minus 3 by 2 0, derivative of 24 divided by x square, 24 constant, derivative of 1 upon x square, first we write x to the power minus 2, multiply by minus 2 index, subtract 1, minus 2 minus 1 minus 3 here, and we get minus 48 divided by x cube. This is the second derivative, and therefore when substitute point here x equal to 4, find the value of second derivative at that point 4. So right side minus 48 divided by x means 4 cube, and this is minus 48 divided by 4 cube means 64, and always this is negative, less than 0. The second derivative negative means we have shown that a is maximum, that is area is maximum and area of printed space is maximum, and therefore we have shown a is maximum at point x equal to 4. So when x equal to 4, we can find y. So what is y? Y is nothing but we have taken y as 24 divided by x, and x means 4. 24 divided by 4 is 6. So x is 4 and y is 6, and therefore we have shown that when the area of printed space is maximum, the dimensions of sheet of paper are 4 meter and 6 meters. Okay, so we stop here. Thank you.